Welcome to lesson 4 of this course. In this lesson we'll talk about how to build deep learning models. First we'll make our own model and our own architecture, then we'll use predefined architectures from Pytorch. Let's go to Colab. Now we're on Colab. First we'll explain how to make your own architecture, then we'll talk about using your own architectures and implementing them in Pytorch. First we'll import the necessary libraries. Then we're going to create a class for our neural network. This class is going to inherit from nn.module, which is the base class for all neural network modules in Pytorch. This class will have a property called network, which will have our model. And models in Pytorch can be created using nn.sequential, and you can stack layers in this nn.sequential object. And we're going to have a forward function which will give the network our input and return the output. And in this lesson we'll talk more about computer vision, because we can use many features of computer vision in Pytorch. So let's talk about convolution. This is how it works. You have a kernel and you decide how big it should be, and this kernel has weights, as you see. And the kernel slides over the input, performing element-wise multiplication with the numbers below it, and then summing all that up, producing an output pixel. What we get is another 2D output, though it may differ in size. Parameters that control the size of the output are the size of the kernel, the stride, meaning how much the kernel travels over the image, and if there's any padding. This image shows a convolution applied to an image, and this image has a padding, and applying padding is very useful sometimes because it allows us to produce outputs the same size as the input. So what's the use of convolutional layers? They act like filters. They help extract information from images. There are many types of famous convolutions that you can find, for example, vertical line detection and horizontal line detection. In deep learning, activation functions are important because they help the neural network model complex functions that are not linear. They introduce nonlinearity into the network, so having them is crucial. The most widely used activation function is ReLU, which stands for Rectified Linear Unit. This function outputs the same number you give it if it's bigger than 0. If it's smaller than 0 or 0, it outputs 0. So this is how the function looks like. Something also very important in CV, computer vision, is max pooling. These are used to decrease the input size. For example, here we have a 4x4 input and we apply a 2x2 max pool layer with a stride of 2 so that the regions won't overlap. For each region, we take the maximum value and make a new matrix as represented by the output image. So here the biggest value is 20, so the first value is 20. Here the biggest value is 30, so this will be 30, etc. And convolutional layers and max pool layers are used repeatedly in a neural network after each other. After repeating, we flatten the layers, reshaping them into a one-dimensional tensor. Then we apply a linear layer on the incoming output, then apply ReLU. We then do the last two steps as much as we want till we have our data transformed to the desired output. So here we apply a linear layer and decide how big the output should be until it produces the size of the output that we like. So here is an example of a CNN, which is a convolutional neural network. Here we call nn.conv2d. We give it the number of input channels, the number of output channels, and the kernel size. And we also have a max pool layer. We give it the kernel size. And if we uncomment this and fill in the values, we'll have a CNN. This is the code for different layers that you can choose from. You can make your own models now by stacking these layers on top of each other. In Pytorch, there's something really valuable that helps us, which is predefined architectures. We use them in Pytorch because they allow us to use architectures that have already been defined. So here we have a class called ResNet model, and ResNet is a predefined architecture in Pytorch, and we have a property called self.network, which is the network, the ResNet 50 model. There are other types of ResNets, like there's ResNet 9, there's ResNet 18, and sometimes we need to modify these models, so we give this model a number, and it takes this number and decides how big the output should be, because mainly when you import models in Pytorch, the last layer produces an output of 1000, but we sometimes want to change that, so we change that by giving the model the number of classes we like. So we change the network's last layer and give it another layer, a linear layer, changing the old output to a new output, giving it the incoming output, and choosing the number of outputs we like. Then we define the forward function, which inputs the data into the network and produces the output. So here we have a model, which we can see its architecture and structure right here. Here, this is the structure of the model. It's a very big model, as you can see. So rather than using nn.sequential, we used one of the models in torchvision.models. We used the ResNet 50 and we modified it so that it would work with our data. That's it for today's lesson. Today we learned how to build a model that is ready to be trained. Next lesson we'll learn how to train it. See you in the next lesson.